Alright guys, welcome back. Today's video is going to be testing on the XB, and specifically what I'm testing is the power that it takes to get to 140 decibels. I'm going to go from say 25 hertz down. So a lot of that is going to be in the infrasonic range where a lot of people don't even play. A lot of people would be wanting to play 25 to 20, you know, the low end of what's normal. I'm going to go from 25 down to 10. So what we're going to do as we do that, we're going to look at power required to do 140 decibels at each frequency. And we're going to look at how the power plays into the output. So I've got Term-Lab set up here, and I made a mistake. You guys have seen me posting. I made a mistake. My multiplier in the past was set to 1x, so I messed up there. Today we are on 2x. So I've got Term-Lab set up. I have my killer bass knob from the Amp Lab and Slam Panda systems. Term-Lab is wired up to one amplifier back here. It's wired up to the bottom one, which powers the right sub. To show you guys what we're working with, I do not have the windows in here. I do not have my filler panels there at the bottom on the sides, and I do not have my filler panel at the bottom here under the quote enclosure. I did put the microphone on the windshield because that's more of an SPL type of measurement, and you guys can see things are just kind of the way they are in here. So with this, I haven't built the horn that's going to come up over the subs and direct air forward. It's also going to reduce interior cabin volume when I get that in. And of course, those block-off panels in the side windows are going to direct more air pressure forward. But for right now, just some fun testing, I'm going to run 140 decibels from 25 down to 10, and we're going to look at the power required to hit 140 in those frequencies. Alright, so we're set up here, and I have my wireless bass knob from Slam Panda Systems, the Amp Lab here. I'm going to go ahead and set this on low sensitivity. I believe it's on medium right now. So low sensitivity, exit, and that's going to give me more resolution on this because there are detents. It's like 24, 26 detents on this rotary encoder. So when I turn it to low sensitivity on this, it basically gives me more resolution on the knob so that each click of the detent is a lower increase in output. So again, we're going to start at 25 hertz. Go ahead, start my measurement and play 25 hertz, and we're going to ramp up with the knob. And you can see just how long it takes to dial back down. So 140.2, that is 140.2, 1,475 watts, and that is showing 1.2 ohms at max SPL. So we're going to reset and go to 24. Do the same thing, start the measurement, play our track, and start ramping up. And I overshot it there a little bit with the 140.7. So we're going to write that down, the 140.7 at 12:03, and we're showing 1.260 on impedance at max SPL. So we're going to drop to 23, reset, and start the track. Oh, wrong way on the knob. There we go. All right, so let's start the track. And a 140.1 at 23 on 790 watts. 140.1, 790, and we're at 1.275. So our impedance is really staying right there at the same spot. We're going to go ahead and drop to 22. It's interesting that impedance is staying the same. Restart the measurement, back to our knob. And that's a 40 on the nose with 677 watts, and we're at 1.286. So we're going to drop down to 21, and then we're going to reset and start the measurement again, and 21 hertz, and here we go. Huh. So that's interesting. If you look right here, we have low power factor inspection required. I know all of my connections are right, so it's going to take some time to sort this out. All right, so I just spent an hour on the phone with Wayne Harris about Term-Lab. What we talked about would, well, several things. First, I showed him pictures of my patch cable, how I have the clamp connected. Then I have my leads with alligator clips that come down to the test leads for the module. He wanted to know that none of this was near anything that was going to have basically EMI interference. So there's no way for that to happen. That's the reason I have these long cables here. Everything's away from anything where current is flowing and causing a misread on anything. But the issue came down to this guy right here, and that is the AI feature on this. Now if we come over here and we look at Term-Lab, we have hardware configuration and there's AI. So right here I can set the minimum SPL for the AI to, it's basically a threshold for power diagnostics, as you see there. So what happens is when I get to 130 decibels, Term-Lab starts looking at the measured parameters versus what it's kind of expecting to see. And if in a situation like this, where this vehicle I'm running tons of cone area and it's IB and I'm getting to the point where it's really efficient, it's starting to see less power, which means current voltage. It's seeing less than it's expecting to see to hit that number. So I'm triggering the AI in Term-Lab. So now we're going to turn AI off and we're going to hit it again. All right, we've got AI turned off and we're going to go ahead and try 21 hertz one more time. And there we are, 140.1 at 21 at 576 watts. and we are at 1.236. So if you look at the tenths point, we're still at 1.2. We're varying on the hundredths and thousandths of the impedance there, but let's go right here and look at the power factor. Power factor was 0.6. So that is what was tripping at 130 decibels. It was tripping the low power factor. So yeah, I'm not quite sure what the AI is doing there, but it was unhappy, and now we've gotten through that. We're going to continue on. So let's reset, get ready for our 20 hertz run. And there's a 140.2 on less than 500 watts. 140.2, and we're at 459 watts, and we're looking at 1.272. Reset, and we're going to go to 19. And again, this is infrasonic. So we're now playing below what they say is the lower limit of human hearing. 19 hertz. (19 hertz), 140 even, 292 watts. 140, and we're looking at 1.363, and this is at max SPL. So that's the impedance we're looking at max SPL. As I do the run, if you guys watch this, you'll see, actually I could set it up where we can watch it in real time too. But right now, 18 hertz. And let's go ahead and dial down the knob. Start our measurement, 18 hertz. (140 even), 253 watts. 253, and we're looking at 1.519. So we have come up a hair on the impedance. We're going to drop down to 17. We're going to reset. And this low sensitivity on the knob means I'm just cranking on it like a winch sail or something. All right. 17 hertz. And there's a 140 even. That's showing 265 watts. Interesting, we came up a little bit. 265, and we're at 1.681 ohms of impedance. So we're going to reset. We're going to drop down to 16. Come down on our knob. There we go, get down there. And 16 hertz. And we're at a 140.1, 223 watts. So 140.1, 223 watts. And look at that, our impedance is coming up 2.183. So we're starting to see impedance rise here. So let's reset, come down on the knob, and start the measurement. 15 hertz. One 140.1, 192 watts. 140.1, 192 watts. So same output, but we're down, what, 30 watts? 31 watts there. And we're at 3.5 ohms, 3.502. So we're seeing the impedance come up here, and we're seeing power go down. So reset. We're going to come down on our knob, and we are going to run at 14 hertz now, infrasonic still. And we're at 203 watts, so 140.2 at 203, and our impedance is 5.411. So impedance came up from 15 to 14, and as you guys have seen me say before, this thing is most efficient at 15. So it has broken in some, but right now we're most efficient at 15. So we are going to do 13 hertz coming up. So that's a 140.3. 140.3, 255 watts. Power's gone up by 52 watts from 14 hertz. And we are at 5.148 on impedance. So our impedance is still 5.1 if you're looking at tenths. We're going to reset and dial this guy back down, start the measurement. 12 hertz. There we go. 140.1, 270. 270, and we're at 4.2 now. 1.4. So we were at 140.1 at 15, and we needed 192 watts to do that 140. At 12 hertz, we need 270 watts to do that same 140. So now I'm going to drop down to 11. We're going to reset. Remember, we're most efficient at 15. So we're going to reset here, 11 hertz. $140.2 at 328. 140.2, 328 watts. And our impedance is 3.372. Now reset, and this is the last run. We're going to do 10 hertz Here we go. And we've got a 140.5. 140.5 at 475 watts, and our impedance is 2.766. So I know a lot of you are wondering, what does this do at higher frequencies? You know, low frequency is great, but let's take a look at what it does at 30 hertz, and then we'll go 35, 40, 45, like that. So 30 hertz coming up. So as you see there, I ended up full knob, and I'm at 3,197 watts. Remember, at 25, I was at 1,475. So it's taken much more power for me to do a 40 at 30 than it did at 25. So I was at 1475 and I did a 40. I'm at 137.2 right now, and I'm at 3197. So as I go up in frequency now, it takes much more power for me to be just as loud. So to fall back to that question of, does it take more power to play low frequencies? As you see here, absolutely not. It really depends on the setup. This vehicle, I can play infrasonic all day long. We're not going to put a lot of heat into the coils. I can play 25 and down like nobody's business. The issue is, as I get up to, say, 25, 30, 35, 40, it takes more power for me to be just as loud at those frequencies. So by trying to demo between, say, 30 and 60, I'm going to put a lot of heat in the coils that I don't need to. I can demo all day at 25 and below, no big deal. This vehicle is going to love that. So I can be windy and not put a lot of heat in the coils. And by playing infrasonics, you can have that windy demo, but still hear the front stage. You're not going to overpower the front stage if you were playing 35, 40, 45, the tap out frequencies, 45, 50. So with this, the beauty of it is I can play infrasonics all day. I can have that windy demo. I'm not putting heat in the coils, and I can still hear my front stage. So in the grand scheme of things, this vehicle is kind of an outlier in the way that it performs. And if you guys have had the opportunity to get into the Audi, it does the same thing. You can sit there at 147 decibels and have a conversation without yelling to the person next to you. And once I actually apply some power to this thing, you saw me come full knob. I've got it turned down in the processor, so we're not seeing full power yet. I have it set up to basically come up to 140 and live there until I get everything completely built, and then we can start getting into the 50s. So I hope you guys enjoyed this. I just wanted to give you a visual demonstration that it does not mean it takes more power to play low. It's really dependent on your setup. So see you guys next time. All right, while editing video, I realized I was clipping my microphone here with the pressure, the waves that were coming out of the back of this thing. As you guys know, I've got the doors closed, but for those of you that have been following the build, down here below this bottom amplifier is the IB opening. It is not a port, it's just an opening down there to allow the subs to breathe in an IB environment. There is no port there. But sitting over here testing this, I was swamping the mic and clipping the mic. So I want to show you guys, like up here, my garage door opener, that flexes. I'm going to show you guys just how much wind is coming out of the back of this thing. So I got to get my phone. And all right, so let's go ahead And I'm just going to set this up over here. All right, 15 hertz coming up. So